I'm very happy to introduce Professor Brian Henderson-Sellers from the University of Technology in Sydney. Brian is also the Director of the Center for Object Technology, Applications and Research. Brian has worked for many years in the areas of object orientation, agent orientation, methodologies, method engineering, metrics, and meta modeling. Brian has worked very much with standardization in the area, and not the least of UML. And Brian's most recent work is focused on how to combine philosophy, mathematics, language use, ontology into conceptual and design modeling languages, and how to improve both the languages and the methodologies for using them by these foundations. And this is also the area for Brian's talk today. So please, Brian, very happy to have you here.
Okay, thank you very much, Paul and the committee, for inviting me here. As Paul said, I have been working in a range of areas and trying to look at commonalities and synergies between them. And most recently looking at philosophy, and I think I'm going to blame Chris Partridge for all this. 3 years ago I was giving a presentation in London talking about modelling, and he asked me the difficult question of what's the underlying philosophy to all this? And of course I didn't know idea. So ever since then I've been trying to find out. And this talk is telling you how far we've got with all that. So, I'm based in Sydney, as you heard, at the University of Technology in Sydney. But I also must acknowledge a number of co-authors on this work over the last few years, several of whom are here today. And they're going to answer any difficult questions at the end of this talk, by the way. They've agreed to that already. So in particular, we have been working with Gerhard Falk and Owen Eriksson at the University of Uppsala. So actually I was pleased to have a 4-month sabbatical here in Stockholm and Uppsala 3-4 years ago. So I actually do know these sort of areas that have been described, and Latin and so on. And been working for a long time with Henderson-Sellers in Spain. But also, as you see there, my colleagues Chris Partridge and Senator Chetara in Britain. And then, last of all, alphabetically at least, my second philosopher, Greg Walkerden, with whom I just spent a sabbatical earlier in the year in Sydney. So I've been playing around with modelling for many, many years, and as Paul said, I got involved with UML. I don't think I wrote that down anywhere. I was trying to hide my UML connection. I actually wrote one of the original submissions to the UML way back, but for political reasons, a lot of our wonderful academic ideas didn't get into UML. Some of them did. I haven't been involved with it. As recently, I've been more involved in ISO standards, which I'll tell you a little bit about as we go through. So one of the things from my experiences with that sort of modelling, and in particular UML modelling, is there are a lot of pragmatic decisions made in modelling languages. And if any of you know the object management group who fostered the UML, it's very dominated by tool vendors. And so there's a lot of decisions into what goes into a modelling language, not based on the underlying research, but to some degree on very pragmatic reasons as to what suits the particular tool that's been used. And so what I've been interested in is saying, well, hey, as academics and researchers, we can actually do better. And here are some good ideas, and let's work on those ideas. And one of the ideas we've been looking at over the years is looking at the mathematical underpinning of these ideas, and then moving on to things like the use of a foundational ontology. We've been looking at the work of Giancarlo, who's here today, and then more recently, as I say, philosophy. So that was sparked, as I said, by meeting Chris 3 years ago, and then working with my second philosopher, Greg Walkerden, and at the end of the presentation, I've got a list of all the publications we've done so far, so there's got half a dozen. So, however, I will take responsibility for what's in these slides today, and also say that this is all work in progress, and so as I prepared these slides, I sort of added a bit of new stuff compared to the written paper, which is in the proceedings, but it may be that there are things there that we still need to develop further. So in essence, the presentation is more an invitation to join in, an invitation to find out what we can contribute to these sorts of improved modelling and design languages. And some of the issues which I'll touch on as we go through, we are the conference of International Conference on Conceptual Modelling. What is conceptual about conceptual modelling? And that's the question we need to ask. It's a question I'm having a talk with Oscar going down to a meeting in Spain many years ago about what conceptual modelling was, and I don't think we ever got to the answers. We ever answered that there. One of the things that I'm not going to talk about much here, but one of the sort of background questions I have in mind is what is conceptual modelling? What a concept, I'm going to talk about that in a second. But also, what is conceptual modelling, which we focus on in this conference, in this community, versus maybe design modelling? And things like UML tend to offer everything. And one question at the back of my mind is, we used to have kind of analysis, design, programming in all silos that never talked to each other. That was one of the reasons why object technology was accepted, because it got away from all of those silos. But I'm beginning to see a lot more drift back now towards the concerns that maybe, particularly in requirements engineering, has become a lot more important in the last few years. And maybe they and us in conceptual modelling, who are trying to look at modelling the real world in some sense, as opposed to UML modelers who are really trying to get a computer solution. And maybe there's an issue that maybe we can't have a general purpose modelling language that covers everything. Or maybe what I'm saying is that if you have such a big language like UML, if you're using UML or similar languages, you get no guidance as to which bits you use earlier in the design, in the development, compared to late. And when you submit papers and get review comments, sometimes the comments are things like, "Oh, this is just a programming influence on the analysis," and so we're not always clear what our assumptions are. And I guess that's probably my underlying concern, is that when you start to look at the philosophy side of things and the ontological side of things, you have a lot of embedded assumptions. Each one of us has a number of embedded assumptions that we probably don't realize we're making about the philosophical underpinnings of what we're doing. And I think a lot of the cross-talk that goes on is not because we disagree with each other, but we're simply coming from different set of assumptions. And I'll flag a paper that Chris and Sergio and myself and my licensed happened this afternoon in one of the workshops, which is looking at the various dichotomies of decisions that you can choose. And say there are 6 binary decisions, then you're going to have 2 to the 6 combinations of things that we all might have, and we might have a different one, all of us. And so we're not sometimes talking past each other. So what I want to try and do is to try and give you some of the thoughts I've had, may or may not be consistent with that, and I'm hopefully I'm putting the challenge out to us all to go that way. So in particular, starting from modelling ideas, and as Paul said, my background is really in object modelling. And actually object modelling, although I got into objects through Eiffel, the programming language, I got away from the language fairly fast, so I don't think I'm too influenced by the languages, but maybe a bit. And then looking at more recently the ontology work, and I worked with Andreas here when he was on sabbatical with me a long time ago. I won't say how long ago it was. And we did some analysis of the WML, which was version 1.2 or 1.3, way back. And then more recently, looking at the foundational ontology arguments, and looking at mathematical underpinning in the set theory. And then when I was in Uppsala with Owen and Par, I was introduced to this notion of language use, which opened my eyes to a whole another set of ideas that seemed to make sense and seemed to help me understand the problems I've been having in modelling from a pure OO, let's say, point of view. So, information systems development, conceptual modelling, call it what you will, that's the sort of space I'm looking at. Okay, let's look at a few details. Well, one of the first questions then is what are concepts? And this comes from a paper that Chris and I and others presented a couple of years ago. And the more you kind of read into the philosophy papers, the more you kind of get a bit lost in what's happening here. Well, we talk about concepts. What are concepts? Well, arguably there might be something in your brain. So that's kind of what we intuitively talk about concepts. We think about the concept of something as something that we create ourselves. But if it's a personal brain thing, it's very hard to communicate that. So how do you standardize it between people? Maybe that's not the right way to go. But Barry Smith, who is a philosopher I've been reading a lot lately, argues very much against the whole notion of concepts along those sorts of lines. So maybe they're representations of something that we think about. There's a philosophical question as to whether that means they do or do not exist in real life. I won't go into the philosophical issues whether real life exists, but that's another problem. Or maybe we think of concepts as abilities to discriminate, abilities to tell dogs from non-dogs. Or maybe they're nothing to do with the mind, and maybe it's to do with the meaning of things. And go back to Frege now at the end of the 19th century. So these things have been around for a long, long time. And one of the things I think we have a tendency to do in information systems and software engineering research is, Google something, and if it's not on the web, then it doesn't exist. And so we tend to end up with references that go back 10 or 20 years, whereas what we should be doing is looking at back to not just Frege, but Aristotle and so on. So there are lots of other philosophers do this. They know about these things, and somehow we as information systems people tend to forget that. And you can see that certainly in the students. That you go to a student presentation, and often they give you a citation, and you say, "But so-and-so published this 30 years ago. Why don't you know about it?" You didn't know about it. That's just by that. Then we can talk about things that describe ontic versus epistemic. And the definitions here, and this is some of the work that Beth's been doing with me, is to do with the difference in things as they are, sort of modelling the reality, the ontological idea. Now, we'll come on to ontologies in a minute, but the ontological idea, or the ontic idea, things as they are, or things as we know them. And so this difference, again, doesn't come out in any of the modelling venues that we know about. The modelling languages like UML can't capture these differences. These might be important, and this might be one of the choices you made as a modeler, but you forget to tell your colleague that you made because he or she has happened to make the opposite choice. And so you've got a miscommunication. So ontic tends to, ontologies and ontic, those sort of words, tend to be trying to describe reality. Although Barry Smith and also my colleague Craig Walker don't argue that perhaps that's not the thing we should be doing. Maybe the philosophers can do that fine, but as information systems people, maybe we're not trying to describe the whole of reality in our ontologies. Maybe we just want to talk about the information systems subdomain of reality. So what do I mean by that then? We know that every person has an age, but in our information systems we might discriminate and we might choose either to an ontic decision where we say that everybody has an age, therefore the field, the data field that describes that should not be null. Or we might decide to say, well, look, maybe we know it, maybe we don't care. What do we know about the people? What's relevant for the system we're building? So philosophers like Smith have said, and I've got a reference right on the very last slide. There's two very good papers of Smith's. One, which is always a philosophy based in Buffalo in the States, he's very much into information system development and the relationship between them. And so there's a couple of papers that I recommend anybody to follow, to read of Smith's, that really set the philosophy ideas in that context of information systems development. But a lot of the philosophical papers are very hard going for me at any rate, because they're not targeted at our domain, but he is. And he argues very strongly that the whole idea of concept, the whole notion of concept is leading us down the wrong path. He also comments on a very common definition of Gruber's, who set a lot of the thinking in this area for information systems and ontologies in terms of an ontology as a specification of a conceptualization. So there you get the conceptualization, that word again, or a version of the word, and then the notion of a specification of that. And so that sent us all down a particular path, I think, and I think most people end up referencing these sorts of definitions. There's also a question about what ontology means, and there are various definitions, but one that we might want to think about is, are we talking about ontology as a study of what exists? And maybe a philosopher, an ontologist like Maria Bunga is going that way. Or maybe we talk about what might exist. And so again, maybe that's a decision that you made without knowing you made it. Some of the work I got involved in is the work that's going on here in Sweden and the work with Urban, and also hopefully work yet with Paul, but we've been talking about working with Paul and Maria and looking at their work, which was presented a couple of years ago at the ontology workshop that Giancarlo organised in Valencia. And the notion of adding or making sure that our ontological works also are socially and institutionally valid. And so the question is there, if a lot of the ontological thinking tends to be, and modeling thinking tends to be thinking about things that are tangible, we can actually identify and touch. And these authors and a couple of others are looking at ways of representing institutional ideas. We're thinking about contracts and things that are part of our way of life and part of our information system, but aren't things we can touch. And so that's kind of fairly new in this area. So there is then this issue of, are we modeling the real world, or are we modeling concepts, or are we, what's the mapping, does it matter? And so some of the questions are, does it matter? Working with Greg Walker, when I sort of discuss things with him, and one of his questions is always, well, will it have any impact on information systems development? And so I went into philosophy thinking naively, all I've got to do is read all about the philosophers and work out which one is the right one for conceptual modelling, and everything will be fine. And the answer is none of them, or maybe all of them, because it doesn't work like that in philosophy. But what Greg has said is one of the things you can do as information systems people thinking about philosophy is to use philosophical thinking to refine your ideas. So kind of work through things without the philosophy, but then look at philosophy in a way of validating the results you come up with and seeing whether they're consistent. One of the other things Smith says when he's, quotes, condemning the idea of concepts is that if concepts are in the mind, then the ontologies that you or I come up with are very hard to decide whether they're good or bad because they're in our minds. So again, he comes away from that and saying, well, what we should go back is the terminology that is often used in philosophy, which is between universals and particulars. So the idea that an individual thing, and we have all sorts of notions in OO and in ER and so on for these different terminology, and sometimes the terminology doesn't matter, I think, and sometimes it tends to set you thinking in a quotes incorrect direction, or not an incorrect direction, but one that has less benefit than others. So the thinking at the moment is that maybe we should be talking in terms of particulars and universals, where particulars are individuals, and then the universals are some collective notion, some conceptual notion, for want of a better word, that signifies what they have in common. What is interesting also, as he notes, is that a statement like a human is a mammal can actually be thought of as both a statement about universals and a statement about particulars. And of course that goes very much against the OMG approach, where everything is an instance of a class and everything in each class is an instance of a set of sets and so on. So how do we rationalise that sort of idea into a standard OO conceptual modelling framework? I'm not going to go too far into the issues of multi-level modeling, but it is something that we need to worry about a lot. So when we're thinking about the software domain and thinking in terms of objects and classes, and I'll actually tend to, I know classes and types are strictly different, but modelers tend to merge the two together. And then we're saying that the class or the type is the software representation of the universal, so they're the collective notion, the conceptual notion, the universal, whereas the particular maps to objects. And one of the reasons for saying that also is that a lot of times you see modelers who can't differentiate between the particular in the real world and the object in the system. And there's a number of papers looking at that. My colleague back at home, Ruben Helker, has some papers on that topic, and I think Michael Jackson also has discussions these sorts of issues. How do you discriminate between the information systems and the thing you're modeling in the information system? And of course, it kind of gets a bit bound up because the information system you're developing is also part of the real world. So it gets a bit complicated. Well, one of the things that I was always sort of underpinned my thinking is also the mathematical ideas. I was trained as a mathematician, so I have keep thinking, that's all very well, but how do you represent it? And so a lot of set theory underpins something like the UML, sort of, and the UML in particular is very much based on the pair of instance set member set idea. Whereas in multi-level modeling, that doesn't really translate across multi-levels, and that's another big issue. What do I mean by that? Well, here is a representation of a customer class, a universal called customer, with particular instances, particulars in there, with individual names. So each of those individuals can be represented as instances or members of the customer set, and there is this general assumption that the members of the set belong to that set, period. That's kind of important. Then, on top of that, you also know, and if you look at the UML or you look at the foundational ontologies used in multi-level modeling, you think, well, each of those sets is an instance of some other set of sets or family of sets. So each of those, so the customer class we had on the previous slide, add on the corporation class, the juridical person class, and so on, and each of those could be a member of another set. We might call that a base set or base class in the context of foundational ontology. And then this notion of set of sets comes in, which is not in UML, and that provides a lot of the problems in there. One of the challenges, I think, also is when you're thinking in this way, and you're thinking in terms, because you're thinking in UML or your terms, which tend to assume these sorts of axioms underneath them, is whether that really is what ontological and philosophical thinking is doing. So there's a potential mismatch or mismapping. It maybe works, maybe it doesn't. I'm still sort of half a mind. What do I mean then is that we can think in terms of different subtypes here of a sortal, which is a typical thing in philosophy and ontology. So you have a sortal type, that is things that can be counted, and there are things you can discriminate. You can say, well, some of them are base types, that is independent entities which supply identity. Identity becomes important in all this discussion. And some of them are role types, things like customers and students, and some of them are phase types. Maybe they're rows, we don't know. Let's stick with three. And so you can represent those as a set with three subsets. Now, then you have the issue of, are you representing things in terms of subtyping, or are you keeping an instantiation? And so this instance of versus subtype of, or kind of, or it is the philosophical term, subsumption. Are they the same? Are they different? There's a paper by Thomas Kuhner that explains these in great detail, but when I showed that to my colleague in philosophy, Greg Walker, then he says, but in philosophy they're the same. And in a sense, you can see why, because each of these are instances of a set, but each of the subtypes themselves are also instances of a set, which leads us on to power types as well, to compatible. We'll come back to that in a minute. One of the questions that has been challenging me for a while, and I have vast disagreements and discussions with people, is whether instant individual particulars can be members of more than one type. And in OO, the answer is no, typically. So if we have a student that is obviously a role type, an instance of role type, but if we model this as, and this is a contentious statement that I'm going to make, if we model that student as a sub-kind of person, then we know the person is a base type, an instance of base type, and so by OO rules, then the student is also an instance of base type. So then the student there is both an instance of base type and an instance of role type. Does that make any sense from set theory, from ontological arguments, from philosophical arguments? I'm not promising any answers to that question, but it's a question that we have to think about. Which leads on to this notion of foundational ontologies. And so the notion then, just like UML, if you're familiar with UML, you know you've got objects, and objects are instances of classes, and those classes are instances of, some call them meta-classes, or just classes in the meta-model, and the meta-model is the definition of UML. So you have these three layers, where the relationship between each pair of layers is an instance of relationships. Now, there are lots of problems with that, but let's just start with that for the moment. Ontologies, similarly, then, you can think about, a lot of the work on ontologies talks about, here is an ontology for banking, here is an ontology for health. And you think, well, what does that mean when you look at what it looks like compared to what some of the work that Giancarlo's been doing in the UFO, as an example, just use, if I may use Giancarlo's UFO as an example throughout. And then, it looks very different, because it doesn't have the same sort of things in there. In the same way that the UML has classes and attributes as classes, and the M1 level has bank account and customer, then similarly in ontologies, a lot of the ontologies that are published look more like a UML model than a UML meta model. And so there's a need for this notion of the next step up, the foundational ontology. What are the ideas underpinning the ontological side of this thing, the complement to the UML meta model? So we're at the same level, if you like, as the UML meta model. And here is this diagram, which I've constructed from a lot of the UFO publications, is a list of things we might think about. A list of things that you may not have come across, that we should think about. So at the top level, we have the difference between endurance and perdurance. Endurance are things that are wholly present whenever they're present. So they're you think of them typically as things in entities. Arguably, at the beginning of this talk and at the end of the talk, you're the same person. And I would recognize you at the beginning and say, oh, you're the same person, yeah. But the talk itself isn't like that, because we started off with a title slide and I talked about where I was from and my co-authors, and at the end I'm not going to mention any of that. I mean, it's going to look very different because it's going to say summary and give us a further reading. So that, the model of the talk itself is actually more of an event, something that has duration, where any time slice of it looks different from each other, and that's what the perdurant approach is. Now, you can take either or both. But you need to know what you're doing. And so the UFO tends, as far as I understand it, the UFO-A particularly, is focused on the endurance side of this, and a lot of the publications of Giancarlo and his colleagues is focused on that, in understanding that side of things. But then there's the perdurant side, which is discussed in UFO-B, but also by a lot of philosophical authors. And I've been reading particularly Theodore Snyder's book and papers, and he's a philosopher that offers something called four-dimensionalism, which is actually a perdurant approach. And the work that Chris will be talking about this afternoon with his work in Borrow is also a perdurant approach. And so you can actually represent everything, throw away the idea of endurance, and go just with perdurance. How can you do that? Well, okay, I said you were the same person at the beginning and at the end, but strictly you're not. So you've probably lost a few cells, I don't know. I won't say anything that you've, again, you lost anything really dramatic, but over a period of time, people, unfortunately, maybe lose weight, gain weight, lose an arm, they change over time, and yet you're identifiable as the same person. which again is an identity issue, which is a big philosophical problem. Let's just get back to this slide for the moment, but that's the difference in what we're worried about. And then you can discriminate between the different sorts of endurance, and in particular, and some of the work that Nicola introduced us to, now 15 years ago, in terms of the sort of quote, meta properties that we might use to differentiate between the various sorts of universals. There's also, by the way, a whole a similar diagram for particulars as well in all these publications. I'm just looking at the universal side of things at the moment. The labels on the side there, plus and minus I and R and O and B, are discriminatory ways of deciding. So, for instance, R is for rigidity. You can discriminate whether things are rigid or not. Rigidity, again, is something a bit like the endurance argument that it's fixed. Once you're a person, you're always a person. Whereas non-rigid means you can change. It's more temporary. Won't go into all the details. The other comment also from an OO point of view is if I draw a diagram like this using OO representation, using UML, then an issue which I'll come back to maybe in passing is, are the semantics of this diagram UML semantics? Do I have to understand this diagram in a UML way? And the fact that most of these subtypings are labeled as disjoint and complete suggests that I am using the semantics, because that's what UML talks about when you are subtyping. It's important. I said in OO you weren't allowed to have overlapping things. You actually are allowed it, but it's not recommended. But you label those with these labels disjoint and complete, which was some of our work that I went into UML. The other OO comment is that in OO terms, each of the classes that are white would be called abstract classes. They're classes that wouldn't have instances in a normal OO hierarchy. In an inheritance generalization hierarchy like this, the only time you'd have objects would be where there were leaf classes. Is that useful, important for understanding an ontological diagram? Okay, I put in this slide to remind me just to tell you about endurance and perturgence, so I think we've pretty much covered that. Here's another example of what I would call, we had UFO as a foundational ontology. This is another foundational ontology that I've been involved in developing, the DEO, which is part of ISO standards. So in ISO, we're interested in standardization of a whole lot of things. So UML comes to my work group, and I've been in charge of creating the ISO standard 24744, and also leading a working group to look at the difficult question, I think it's very difficult question, of finding a way to make ISO software engineering standards talk to each other. At present, what happens in ISO, although it's a lot better than IMG, what happens in ISO is that any standard gets allocated to a particular working group, and there are a dozen of these just in software engineering. And so they develop the standard. And they tend to develop it in a silo, and it's standardized and they're fine. But an industry comes along and wants to use, let's say, 24744 and 15501 and 33000 series. I can just put a few numbers, these are just numbers, I can't tell you what they all are. But they want to do process modeling, process assessment, product modeling, quality assessment, metrics. You know, there's a standard for each of these. But each of those potentially has a different set of axioms. And a lot of them, to be quite honest, have no real axioms at all. One of the things we did was we tested actually the 33000 series, which is software process assessment, against one of these models. And we found there were things in there that weren't in the terminology, even in their own terminology, and things and vice versa. So one of the things we're trying to do is say, look, if we had within SC7, which is the software engineering standards ISO, a single point of reference, for want of a better word, then we could make sure that all the standards that were created in the future conform to this particular standard. Well, this reference that we're proposing, this has not been accessed, this is work in progress, and is the DEO. The idea is that the DEO is essentially a foundational ontology for the part of software engineering and information systems development that is of concern. So it is really, it has to encompass all the work in process modeling, which is essentially 207 and 24744, the work in software process assessment, which is 15504, which is now will automatically become the 33000 series, and also there is a SE vocab, which is a software and vocabulary standard, which has a lot of terminology. Now, to give you an example, if you look at SE vocab and look at a word like task or process, you'll find like 8 different definitions. If you're lucky, maybe 10. A lot of different definitions, one from each different standard that deals with this. And of course, none of them say the same thing. So the idea is then that you take a DEO and you make sure that the definition of, let's say, task here is tight enough that it's first clearly defined and also can be expanded. And I'm not going to go, I've only got one slide on this, so I'm happy to talk about the details of this later if you wish. But the idea then is that you have a very tight core of definitions that everybody accepts, and then that each individual working group can then expand on that core in an OO sense of generalization, specialization, so it becomes that core with their particular specialized terminology. And so you can get a mapping back to this particular core at any time. And so that any new standards that are proposed would have to conform to this. Now, that's the idea. We've published a couple of academic papers on this idea. It's still to be actuated. It takes a while to get these things accepted. There is resistance. I can tell you there is resistance from certain countries to the whole idea of ontologies, and the whole idea of meta-modeling, and the whole idea of conceptual modeling. And you have to overcome. There's a lot of marketing going on. Anyway, end of that. One of the things that this whole led me down, and myself with and Owen, was the notion of philosophical identity. Because there is this notion that a base kind, you need to have entities that have identity, and according to a foundational ontological approach, only base kinds can supply identity, whereas other things kind of have to acquire them and carry them in some other way. So an example is a person has identity, but a student, a role, doesn't supply identity, but can carry it, has to acquire it from somewhere else. So you start to look at all the identity definitions, and we looked at a whole lot of literature, both from philosophy and ontology, to work out what it meant by identity, and it's not an easy answer. We did publish a paper earlier in the year from the Asia-Pacific complement to this conference called APCCN, which I'm chair for the next 2 years. So please submit your papers to APCCN. I can do Steve's output today. We're meeting in Canberra in February with that. That's all now tied up next year, but the year after, I'm open to ideas for people to come and talk to us. I want a nice trip off. I won't have any money, by the way, but you can come anyway. What's the criterion of identity? Even if you want to work out what the identity is, how do you work out how to, a person's identity, we all think of, we know what that means, but when you have to write down what that means in sort of attributes, for want of a better word, what is it? And that's not obvious. You might say it's DNA, but then what happens with identical twins, or maybe it's fingerprints, or what happens when people have lost their hand, burnt and lost their fingerprints. So language use then starts to talk about this. What about non-material institutional entities? How do they have identity? They don't have fingerprints. So there's whole issues of identity there. And identity sort of pervades a lot of the thinking in this area. So this notion of foundational ontology is also stressed the supplying versus carrying of identity. And once you get into, say, the philosophical literature, and a good place to start if you're interested in the Stanford Encyclopedia of Philosophy is a good place that has lots of articles on these sorts of issues. One of the rationales that got me into these sorts of ontological, foundational ontological thinkings is the proposal that Giancarlo made in the thesis and since, that maybe one of the ideas would be to offer these as extensions to a language like UML. And so that sounds like an excellent idea. Of course, if you're going to do this, not only do you have to navigate the whole politics of the OMG, but you have to have a pretty good answer as well. One of the questions they will ask is, why? They always ask that. I mean, if you want to make some sort of improvement, they say, well, it's all right as it is. I remember, I'm not sure I kept it, but I got a reputation for, I think, putting in the most questions and challenges to the early versions of UML. And hundreds or so. This bit's wrong, this bit's wrong. And I remember getting an email from Jim Rumbo at the time that said basically, yes, Brian, you're right, but we're not doing it. Because it's good enough already. So there is this feeling that it's okay, it's good enough, we can get around it. We know how to work around it. I don't like that as an attitude, and which is one reason I moved away from OMG and went into ISO, because I think they're a bit more open to the idea of rightness or quality than the OMG, who have this satisficing approach to life. That's what I like. So this idea of offering up foundational ontologies as an extension to a conceptual modeling or modeling language like UML seems to be a good idea, but we need to think about what it means. And at the moment, a lot of the work that Giancarlo's been doing has been towards the end Euro model, I think it's fair to say. The key concepts are things like sortals and rigidity, and the notion of supplying identity. But we need to sell that to the UML community, and we need to get it right. So the sort of thing that we might end up with is here, the top couple of classes here, classifier and class, are UML things. But the UML stops at class. The most granular thing you can do is class. Now, this is one of the reasons I think Giancarlo and myself are saying we want to do this, because we're saying we can add more granularity to the UML modeling capability by adding in things like sortals and mixins and rigid sortals and so on. And that should give us the ability to model better, shouldn't it? Now, I can't prove that, that's the problem. What is needed, empiricists out there, we need some proof of all these things. We need to prove that by adding these extra classes, which of course adds complexity, think industry user. Industry user wants to get the answer out as quick as possible and as good as possible. They don't want to have to learn 5 more, 10 more bits of UML. Is this a sort or non-sortable? Is this a mixin or a non-mixin? They don't want to necessarily do that. So as researchers, we have to make it easy for them to do that. So I think it's a good approach, but I think we need to think very carefully how you do it. One of the challenges we've been worrying about for a while is role modeling. And again, this has got lots of contentious papers, contradictory papers, different philosophies. So I don't pretend to have an answer, but I know lots of questions. Clearly, in a foundational ontology, we have role types and base types, and we know that base types can supply identity and role types can't. They have to acquire it. So one question is, how do you acquire identity? And because a role type is a non-rigid sortal, whereas a base type is a rigid sortal, then can I have one as a specialization of the other? Well, I would argue that if you're using UML semantics, which I believe to be one way of thinking about this, is that you can't. The rule in UML is done by an OCL constraint that says basically that I can only have subtypes of things that are direct ancestors of me. So I remember the diagram, you may not, but if you have role types, then you have non-rigid sortals, and then sortals, and then substance sortals, and so on. You can have an generalization structure with any of those. But base kinds are in a different leg of the tree, and you can't relate them by generalization because they're not direct ancestors. That's an OCL constraint, and for very good reasons in UML. But one way that you do this, and UFO does this, is it says, well, I want to do this intuitively. I want a role to be able to acquire its identity from a base kind. And I think here is where I have a challenge with Giancarlo, I'm afraid, if you forgive me. The way they do it in the Giancarlo does is he actually puts in a textual override that says that essentially the role type there is a subtype of, or can be a subtype of base type. the horizontal line at the top there. So, added in, we've done it visually, we've done it textually, that allows you to do this. So that's our UFO on the left allows this. I worry about this, and the work that I did and published with Owen and Power a couple of years ago, where we offer a slightly different approach based on language use, says that on the right-hand side, if we model this, granted in a more complicated way, we've got for 4 classes rather than 2, but we don't have any specialization relationships, we simply have instantiation and associations, so that Peter is a kind of person, an instance of person, and people have roles, and Peter has a specific role of a student, and the student is there for an instance of the role type. And that works as what we call the role type pattern. And it works from a language use point of view, it works from an OO point of view. It's a little more complicated, it seems to be arguably a more interesting way of doing things, a more reliable way. But this is at this point for discussion. If you also think in terms of roles and endurance, perdurance, set theory, then you get into a whole lot of problems. A set really has members that are permanent. Peter's a student as a member of a set of people with an attribute or state of being a student, of course, may move in and out of being a student. Today, he may be a student. In 3 years' time, when he graduates, he's not a student anymore and becomes an alumnus or a professor or an industrialist or something. So what does that mean in terms of set theory? Does that mean that you have to have a new set after this person's life? Can you allow people to move in and out of sets? In terms of endurantist approaches, I understand it, that really wouldn't work. And maybe, I started out as an endurantist, I think, and I'm now becoming a perdurantist. Mostly because I've spent some time with both Greg and Chris. And reading Sider. Sider was very compelling, actually. Sider, the book, Sider's book on Four-Dimensionalism, calls them four-dimensionalism. And it kind of says, here is how you do it in an endurantist approach, and here's what's wrong with it. Oh, by the way, you know, although he's arguing very strongly for perdurantist, he does it in a very fair way. He actually says what's wrong with the perdurantist approach as well. You know, he's not saying one is perfect. He's just saying that maybe we should think that way. And I'm suggesting that we should look at those sorts of issues. So the temporal relationship between these two approaches in terms of roles is what Sergio and Chris will be talking about this afternoon. So I'm not going to steal their thunder by telling you all what's in this afternoon's paper. So key ideas in this sort of work is to do with rigidity, key idea of things, whether they're rigid, key idea of identity, whether you can supply it or carry it, and then identifying that criterion of identity can be problematic. Another philosophical idea that I've seen discussed around, and I've had some discussions with Giancarlo about, is the idea of an individual concept. Although as I understand it, it's currently out of fashion. There's a paper very recently that kind of argued that maybe there was a couple of areas where it could be an approach. That's the idea of a single, an individual entity, an individual particular being modelled as a class. We can talk about that later if those are interested. But it's kind of a totally different way of thinking about things. I don't think that way in terms of modelling. Well, what about the social perspective, the language use perspectives, and the work that I've been doing with the Conceptual? The speech act theory says that your first statement has to bring something into existence. So before I can start to converse to you about, talk about Oscar and Valencia and things, okay, he spoke, he was introduced to you, but until you knew who he was, you didn't know. If I'd started this talk with, Fred tells me that, and you think, well, who's Fred, But if I said, well, Fred was my tutor at university, and Fred says, then it means I brought him into existence, essentially from a language use point of view. So it's amazing how many times you kind of read things or hear people start talking about things that they haven't introduced into the conversation. They start the paragraph with a pronoun. And I think, well, what does this pronoun refer to? What are we talking about? you need to start with that. And I say that because there is a feeling that UML modelers do that. They start talking about things as if they already existed. So there is an axiomatic idea that things exist before we bring them into existence. And in language use, you don't. So there's a few slides on language use for those who are not familiar. Speech acts. So if I start by telling you Fido is a dog, that's called an existential proposition because I'm introducing into the conversation this individual and telling you something about them. I'm setting the context. So I've told you that this instance is a particular. I've told you that it belongs to a universal called dog. And I can represent it in a traditional tabular form as dog name is Fido. Okay. If I now tell you that Fido is 50 centimeters high and Fido is brown, then I'm adding information to that. What I could be doing from an overlapping point of view is saying, well, Fido here has now attributes with values, has a name Fido, height 50 and colour brown, and that means that in the class to which Fido conforms, the dog class, I need to have attributes with those names. So in our terms, the normal rule is that you have attributes declared in one class, and if you take an instance of that class, then you must put attribute values to those attribute names. That's the basic rule of type instance semantics. I say that strongly because that is also highly relevant in multi-level modeling when you can't do that. And one of the problems with process modeling, and I'll show you power types how that works, and this is an issue. And the work I've done with Colin Atkins and Thomas Kuhn, and the work they've done together with each other, is a whole series of papers that they've done along these sorts of lines in terms of how UML doesn't support these sorts of ideas and how to do workarounds, particularly when you look at UML semantics applied to process, which makes it very difficult. So that's the speech acts. So we could put that as a table and put some extra columns in the table with values in, and that's fine. The challenge comes when you say, oh, by the way, Fido is a collie. Because you can't say, Fido is a collie. I got told off many years ago for using the term is without telling you what I meant by it. Because could mean is an instance of or is a subtype of. And in common parlance, in language use, you know what you're talking about because it's part of language use and part of the language you learn. But from a formal point of view, it isn't actually clear. Here we are implying that Fido is an instance of collie. But I've already told you that Fido is an instance of dog. Colin and Thomas's argument then is that there is this difference between two sort of linguistic metamodeling and ontological metamodeling, which personally I don't agree with, but their argument, which was back to 2003, is to try and understand what breed is. They argue it's a metatype in an ontological metamodeling context. I argue that it's actually an instance of a moment universal in an ontological point of view. So there's these are some of the discussions that are going on in the literature, in the background of the literature now. So I can't put Fido as an instance of collie because Fido is already an instance of dog. But what I can do is put breed as essentially another attribute, if you like. Say in ontological terms, it would be an instance of a moment universal. Okay. Another issue is in UFO-A, a role type is a subtype of a substantial universal. It's my understanding that a substantial universal means universal that represents something that has substance. In other words, it's tangible, it's fixed, it's a thing, it's made of matter, made of substance. There is, I know, a term that's grounded in substance or grounded in matter, which also seems to have the ability of creating something that is institutional in terms of something that is physical, but this is something I've been discussing with Owen yesterday, and we still don't have an answer, so discussion point only. Roles, therefore, because they inherit from substantial, are also implicitly made of matter, and I worry about that. I know that some philosophers, and maybe Chris, I think Chris argues this way, and Greg also argues this way, that you can somehow make that connection. But it's an interesting question to my mind as to how you link the non-materialistic, institutional, social, whatever you call it, into more of an endurance argument, material world. One of the things we suggested, or are suggesting, that if we want to make this explicit, a bit more explicit, it currently is in UFO, and I've taken the UFO on the right-hand side of the UFOA, and argue that maybe we need to think about the work that Paul and Maria and Owen have been doing as another branch under the universal, the enduring universal tree, and create a social universal in the UFO sense. And that would allow me to have the components of rigidity, non-rigid, and so on, all the same sort of stuff, but allow us to include the more institutional ideas that are floating around at the moment. And if I do that, I personally would like to put wrong time on that side of things rather than under the substantial universal, but that's just a personal issue. Well, one of the things we've also talked about is all this is aimed at making better modelling languages. And as I said right at the beginning, one of the underlying questions is, can we actually make a good modelling language for whatever we want to call it, requirements engineering, conceptual modelling, analysis, design, programming design, can we do that, or do we actually need several languages? And I raised this with my colleague Cesar González-Pérez in Spain a few months ago, and he said, well, he took the idea of many, many languages, and he has a language called ComNL. He's working now, he worked with me in Sydney for a while, but he's working particularly in a heritage area, which is sort of archaeology and sociology, an area I know nothing about, but he's in his area where he's trying to get modelling introduced to people who are going out in the field and finding shards of pottery and classifying them and all this sort of stuff. That he has a sort of nest, almost kind of what is the Russian doll nested idea, that he starts off with a particular set of modelling constructs that he applies early in analysis, and then adds to the language, and has, I think, 9 stages of language as he moves through, becomes more complicated, more sophisticated. Should we do that in information systems development? Should we identify what we need for requirements and what we don't need until we get to detailed design? And I guess some of the ideas that are around in requirements engineering and in sort of the MDE world, where we're looking at the sort of work Oscar's done in terms of the theory of electric decay over, where you're doing actual machine translation and diagrams into code, all are relevant and important, and the very great interest over the last few years of domain-specific modelling languages that there are a few papers I think here this week. So we kind of put together a list of, kind of wish list of what we're interested in, and this was presented at ICSI earlier in the year in more detail. Just to summarise this for you here, some of the issues that we think this idea of a multidisciplinary approach might offer. So why we're trying to offer them. The first problem is, one of the problems that we're looking at is the notion that, as I just said, that really, although UML calls itself a general purpose modelling language, having been involved in it, I know it's really a design programming language design. I don't know. At least that's the bias. And when you look at the inputs, you see that the people who have most influence UML are people like Greg Gooch, for instance, who, when challenged, says, well, I've always wanted to be a programmer approach. That they're kind of, designers or modelers not by inclination, they're really programmers by inclination, and they're also probably involved with tool companies that are building tools to create code. And so there is this bias in the thinking there. So, I use UML as an example just because I'm more familiar with it. So there is the idea that really languages, many of the current languages have this late system bias. One of the things I referred to or in passing is this notion of the 4 levels. There are currently 4 levels in the UML hierarchy, and Colin Atkinson, Thomas Good and myself, Cesar González-Pérez have written many, many papers arguing why this is a problem and how we should get around it. There is this reliance on type instance semantics, which is 2 layers, but then extended to 4 layers, without any real proof that it works. And in reality, they're talking about sets of sets, and sets of sets and sets of sets, but they never say that. And that's implicit and not recognised, and maybe has repercussions that they wouldn't want. On the left is a typical UML diagram that almost any UML modeler would sort of accept and say, well, a parameter is an instance of horse. The horse class itself is what we typically include in our modeling diagrams, and we recognise that horse is a class. It's the horse class, and therefore it is an instance of the thing called class in the UML metamodel. But you therefore have that parameter is a horse is a particular an instance of a class called horse. So horse is a class. If you start at the top, you say, well, I've got this class called class that has instances, and one of those instances is called horse. So you end up with horse being both an instance of class and a class which has instances of actual horses. So is horse really a class, or is it really an object in a UML sense? And of course, well, Colin's answer is it's both. He calls them objects. It has a facet which is both a instance facet and a type facet. Well, what does the industry modeler make of all this? We think that what they do is they just automatically, almost without thinking, do the fix on the right that says, well, we've got some object of type class, we better map that to a class in our diagram, and we'll call that the horse class. Now, that step through the thing that's there of object1 type class is really just kind of just whizzed through as a definition, but theoretically it doesn't work really, it doesn't really hang together. And so one of the questions is, can we as researchers develop a better multi-level modelling hierarchy that will do this? And I'm doing some work with kind of Clark at Middlesex, no, it wasn't Middlesex University, just then we moved to Sheffield Hallam in the UK, where we're looking at what other ways round this. And some of the work also that Colin Atkinson is doing in Germany is along the same sort of lines. So again, work in progress. In particular, one of the difficulties with all this multi-level stuff is merging product and process models. But even if you believe this instance of stuff for product models, as soon as you start to do this for process models, which is my major interest, if you like, is that it doesn't work. So that you have a type of person that is producing, so you have a, let's say, an architect who's producing architect diagrams, but architect diagrams are particulars, whereas the architect in the process is actually a class. So you have classes that are related, apparently, to particulars, but if you draw that as an UML diagram, you find it crossing n levels. In UML speak, it's n0, n1, n2, n3. So you have things that are in n1 linked to things that are in n0 with an association. And that is not allowed. Associations have to be within a layer, not across layers. The rule of strict metamodeling in UML is that instance of has to be between layers and never in a layer, and that all other relationships have to be within the layer. Now you can argue with that, and many of us do argue with that, but that's their rule, and that's the way it's structured. And so my question as a researcher is, what's the better answer? So once you do this in terms of process, you have all sorts of challenges, and here is our answer to this, and this is power types. Well, the Jimmerdale called them power types in 1994. They're actually families of sets. They're not strictly power types, but we'll call them that for the moment. And the basic idea is that you have in the meta level, which is we've put at the bottom here, just for other reasons I'm going to. And instead of one class, you have two. You have one that represents the kind of it and the thing itself. And the trick or the usefulness of this in the power type is that you take an instance of I'll use the words on here, an instance of document kind, creates a thing that is also a subtype of document. So you have a thing in the N1 level, which is the model that you are creating to describe your methodology. So the middle level is the methodology that you're going to hand out to people. And you have a thing called requirement specification document, which is a subtype of document, but an instance of document kind. And the advantage of that is that there are things about the requirement specification document which apply to all requirement specification documents. These are values that are got from the document kind, because if you remember, when you take an instance of relationship, the attributes that are specified on the top level, document kind, which here are name and must be approved, are instantiated. They're given values. And so in this case, the name is given, requirement specification document, and must be approved is a binding value which is given the answer yes. And that applies to all requirement specification documents. But there are things that don't apply to all requirement specification documents. For instance, the version number, maybe the time it takes to create it, things that are personalized for a particular project. So at the endeavor or project level, which is the My System requirements documentation, then you need things that are values at that level, which are declared 2 levels above, or in my inverted diagram, 2 levels below. You can't do that within the OMG hierarchy. So Paradox breaks the hierarchy. It's one way of doing it. Colin and Thomas have a thing called potency, which does exactly the same thing, which is, but with, in my view, less theory, but there is another way of creating what they call deep meta-modeling. Allows you to put attribute values, to defer attribute values across multiple levels. But the problem was to put values in the endeavor level that were declared in the meta level, across 2 levels. This is one way of doing it, potency is the second way, but it needs to be done. UML can't do it. Then you think about language use, and you try to set all this in terms of language use and some of the work that Chomsky did, and in terms of language use, language definition versus language use. And maybe, this is sort of the proposal we had in the 2013 paper, maybe another way of thinking about it is that at the top level, or the quote, meta level, we don't have a meta model, we have language definition. So we think in terms of language rather than in terms of meta model. You know, if you're in the OMG world, everything's a model or a meta model. Language does, although UML is a language, the level for language kind of doesn't get very much prominence. And then the issue about dogs and breeds and collies all becomes language use, and then you can start to see the dichotomy of linguistic and ontological meta-modeling and Colin and Thomas's in a different light. And you can start to see how the language use that I've explained in terms of thinking about collies as being instances of breed, where breeds are moment universals, so they're different parts of that UFO ontological hierarchy in a very useful way of thinking about it. And so at the top you have language definition, and maybe you want to define that language in a modeling language sent by a meta-model, or maybe you don't, maybe you want to do it some other way. So if you shift your thinking, and it's a fairly small shift, but has, I think, repercussions, useful repercussions for us, is to think about language rather than meta-models at the top level. That then links you into all the language use, and you can start to look at the work that's been done there. Another comment on this diagram is one from Owen, which is that the correspondence relationship between the object, here, rover, and the actual rover is something that should be made obvious and explicit, and sometimes gets lost. As I say, Movement and Helper back in Sydney also has similar sorts of notions from, he's an industrialist, and he also comments on this a lot. So maybe that multi-level, 4-level that I talked about is replaceable by something like this. And the difference there is that we have put that language in the top level and put on the side the meta-model side. This was published in paper 2013. Okay. The third is the language use evidence of things to do with general purpose modeling languages, and some of the work that Per and Owen have done, and I'll let them describe in more detail if you want to talk to them, is on the social idea and personal identification, and was a paper they published 5 years ago. And that led them to look at this social ontology. This is from Paul and Maria and Owen's paper, which starts to get us thinking about how does all this social stuff fit into the UFO side of things. And this was part of the discussion we had at the conference we were all at in 2013. I was the commentator on their paper as it happened 2 years ago. Then the philosophy side, again, the challenge that Chris said, Is the philosophical approach coherent in the ways we think about things? The ontological epistemological concerns are often confounded, certainly in something like an UML there. So the philosophical insights, as I've said, is that I thought I was going to look for the answer, and it turns out there is such a diversity of philosophies. As a scientist and engineer, I build on authority, I build on previous results and cite previous papers. In philosophy, apparently this is not true. You're not allowed to cite somebody as the right way or the better way or whatever. Just a way. So that leads one to be told that no one philosophy is going to be correct for us as conceptual modelists. And therefore we shouldn't think of it as a base point. We should instead, think of it as not a base point, but also a resource really to help us to go forward and think about things. So what I'm suggesting to you as a body of research is that there's lots of research ideas here that you could take up and go forward with. And an aim is by using this integrative approach and not just thinking in terms of ontology or just thinking in terms of language use, that we can together get a more theoretically sound approach that is consistent with all these things, language use and mathematics. I know it's all over, but it's kind of interesting. And maybe we should consider, as I hinted at, separate analysis and design modern languages. I'm agnostic as to whether there's a yes or a no there. We definitely need practical tests to evaluate all this, and because I'm interested in standardization, I do think that these sorts of ideas eventually would end up being standards. Why do we want to do all this? Well, I think, again, making the philosophical basis made more explicit, thinking about language use and speech acts, thinking about ontological commitments, thinking about general purpose versus brain-specific modeling languages, thinking about how we can link product and process ideas seamlessly, worry about roles. Again, there's quite a literature on roles in all sorts of aspects of roles in software engineering, information systems, philosophy, and so on. And although I haven't mentioned it, the mereological issues of whole-part relationships, which is, again, another important part of modelling, which UML has made such a mess of, in my personal opinion, and I'm quite happy to give you the reasons for that. And again, I've been doing some more recent thinking on that. Then there are some philosophical issues like temporality and vagueness that can be captured perhaps more easily by thinking about philosophy. And the whole aim, of course, is to try and make industries more easier to use and so on. So again, that's sometimes a bit of a contradiction in we as researchers put out all these ideas and the industry people say, well, that makes it too hard. So, current meta models to modeling languages, for instance, UML version 2, tend to ignore all those ontological ideas, which we could ask potentially as subtypes of classifiers. That most modelers, industry modelers, even researchers often ignore the whole ideas of foundational ontology, particular language use and philosophy and even sometimes mathematics. And that we need to link also, of course, things to the real world. So my summary is that I think there's been little philosophical influence on conceptual modelling to date, or at least not explicitly. I think that inclusion of these ideas, and of course ontology is a subtype of philosophy as well, so ontology and philosophy are mixed together. That there's no holy grail of all this, but including it can, I think, open our eyes to a whole number of ideas, and particularly moving towards universals and particulars might be a better terminology. Terminology sounds trivial, but as I say, from my experience with ISO, it's actually the terminological issues that stop good modelling. The idea, as I said, with SE vocabulary that has 8 or 10 definitions, everything you can think of in ISO standards that not contradict each other necessarily, but don't work well together. And so people with different terminologies tend to talk across each other while thinking they're saying the same thing. And then we just need to be aware of some of these ideas. So good models, although it's hard to prove, help significantly in producing good quality software, and that we can help by having good quality modeling languages. Now that's probably more important for novice modelers than sophisticated modelers, of course. Again, we need empirical evidence to prove all these. Current modeling languages, and use UML as an example, have many flaws and incompatibilities. They don't take into account philosophy and they tend to be contradictory when we get there. So, challenge to you all. Can we do this? Can we find and utilize this new architecture that combines all these things together and makes it a wonderful package and is useful to industry and can be implemented? That's another challenge. if you're interested, we have published a number of these papers so far. I can give you those references if you wish them. But I will also encourage you to read these two papers of Barry Smith's, which I found really eye-opening and highly relevant to what we're talking about today. Thank you.
Thank you all very much. I think we have time for one question or so.
I know John Carl. No, I'm not actually answering John Carl.
Okay.
You did have that up first, I knew you would.
Of course. Thank you, Brian. It's very interesting to see a talk that brings attention to ontology and shows the importance of trying to put these things together.
Okay. And I'm personally very flattered that you were, UFO triggered your interest. Of course, I disagree with many things, and I'll have to give a different talk to explain.
Well, don't wait around, I can't hear.
Oh, okay. So there are many issues that I could comment on, but we won't have time. Maybe I should come to Australia, next year and do this. But I will. There are things which I obviously agree. The thing on partial relations, you are completely wrong. We could talk about that later. Also, I agree with you that these things can make a huge impact on modeling, but we do actually empirical evidence for that. We can also talk about that later. I will just comment on the thing that you said explicitly we disagree. It's the thing on roles as being subtypes of kinds, right?
I know we disagree. We just have to go a lot further.
Okay, but I can make a case that what we made there on saying that you create a contradiction saying that student as a subtype of kind has to be an instance of base type. It's actually it's a logical mistake. You don't have to do that because if you have subtyping and membership, they are not transitive. So there is no way you can get into that conclusion. Another comment is on the UML side. So the OCL constraint that you mentioned that is there on the UML model is true, but it's also said in the specification that you can override that in the case of UML extension. And the reason is very good, because what they did there, what they want to guarantee is this kind of deep disjointness across all levels, because you don't want to mix up instance of, let's say, data types with instance of classes, or instance of association and instance of classes. But once you said yourself, UML stops there. Once you can create specializations of UML class, that constraint makes sense. Overriding that constraint makes perfect sense. And we did it, and the proof that this creates no contradictions that we implement all these tools using UML tools, moth tools, and they work. My third comment was related to the issue of roles. The issue of founded on error, let's say, it's actually quite compatible with a view of UFO, in which, in UFO you can actually think of roles in two different ways, right? So you can think of roles as the entities that play the roles, like you and I, so you play the role of keynote speaker now, and this thing is an object, it's a substantial, right? Of course, there is something else which you can think of. It's a kind of moment. It's all the qualities of you as a keynote speaker. So this Brian Qua, keynote speaker of PR 2015. And I think that thing would correspond to your role instance. And that thing in UFO doesn't have to be founded on matter in this interpretation. So no disagreement there. So I was just pointing out that maybe the disagreement is even not that much, right? So there are things that I think we just have to sit together and communicate.
Converging to an agreement about something.
Yes. And on the first 2 points, I think...
What's the question there, Giancarlo?
No questions, just a question. Sorry for that.
One of the things I thought was you have to be careful, and I'm not criticizing you because you have to be careful. You started off by saying UML had many flaws, or I was wrong. And then you quoted something that they allowed an overriding. And you accepted that. And I think we have to be very careful then if we are criticizing UML or whatever, why are we doing it, and are the bits we're accepting, if I may, think about the Bible. You get people who give you a quote from the Bible, and somebody else says, 20 pages later there's a total contradiction. And you've got to be careful that you're not cherry picking.
I'm not looking at that. I agree with you, you should do that.
I think we've agreed to have a discussion later in the week.
This distinction itself says you can override in certain cases, so I'm following this distinction.
Okay, thank you. And thanks again, Brian, for a very interesting talk, giving us a lot of food for thought for future work. And now, before finishing, I would just like to hand over a small Please, Brian. Thank you, and thank you again.